Hepzibah.
Hepzibah, you can start, ma.
Good afternoon to one and all present here for this valuable webinar. I am J. Hepzibah Malin, IEEE APS member. On behalf of St. Joseph Institute of Technology, I am here to volunteer for today's session. Now, I would like to extend my first and foremost gratitude to our Honorable Chairman Sir, Dr. B. Babu Manogaran, our Managing Director Ma'am, Mrs. P. Jessie Priya, and our Director Sir, Mr. Sashi Shekhar, and our beloved Principal, Dr. P. Ravichandran Sir, for giving this opportunity to conduct the webinar. It's my pleasure to welcome Mr. Naveen Kumar Sir, the wonderful speaker of today's session, who's working as System Engineer in TCS. And I thank you, sir, for making your presence here. I would also like to extend my gratitude to our head of our department, Dr. C. Jnana Kausalya ma'am, Staff and Student Affairs, and Dr. G. Rohini ma'am, Lab Affairs, for their ceaseless support. Before we start this session, I would like to tell a few instructions to be followed by the participants. Kindly post your queries and questions in the chat box, and they will be discussed with the speaker at the end of the session. The attendance link will be posted at the end of today's webinar. Now, I invite our speaker of the day to kindly start the session.
Yeah, thank you for a wonderful introduction. Hello everyone. Today I'm going to talk on the topic IoT in smart agriculture system. As we discussed, IoT is in everything, which we mentioned before. It's the Internet of Things. The future is around this. The present, which we roll around, is also working on IoT. IoT in various platforms, in various application modes. But what we think, we have to implement something in agriculture. So we plan to implement IoT in agriculture. Okay, before going to do why we need to do this IoT thing in agriculture system. We all know, we all speak from our childhood, we have been learning a small thing, agriculture is our backbone. But what are the wastages we are making this? Well, irrigation itself, we are wasting 55 to 75% of water, which we use for agriculture. Same work on the whole, if we do something to the agriculture side, we can save 50% of water which is used to agriculture now. To achieve this thing, we are going to implement the IoT in this. We will check how to do this. The table of content today is which way we are going to help farmers, what we are going to use, how we are going to implement. If in any application towards IoT, if we are able to answer these three things, we can achieve it easily. Now, which way we are going to help farmers? Yeah. Before that, I have one quote. It's the most famous quote and most loved in myself. Science can be amused and fascinate us all, but it is engineering that changes the world. When you going to implement something involved with engineering or something, you have to know the science behind that. If you know the science behind that, you can use it anywhere, any place. Now we go on to the topic, which way we are going to help farmers. First, we are going to note some of the problems faced in the agriculture nowadays. First thing, farmers pump the motor more or less to the cultivate land. Each cultivate land have different need a different amount of water. One land need some 50%, one land need 70%. It depends on the what is cultivated in the land. It is known by the farmers, but farmers don't know how much water is flowing inside that. To find that, we are going to use moisture level to find the moisture level of the soil. Second thing, sudden rainfall. Even though farmers can predict when the rain comes in the evening or like that, but they don't know the sudden rainfall because their farming land won't be near to their home. So to detect that sudden rainfall, we are going to use rain sensor to detect it and notify the farmer. And then temperature and humidity of the farming land. This is the live tracking of that. What's the temperature going on now? What's the humidity level? We're going to track it and show it to the farmers. And then fourth thing, switch. Uh, this is to make farmers easily to do some jobs like switching on or off the motors or some other electronic item which works on switch. We are going to make it as a mobile-based application where farmers can just have a click to on or off the motors. Okay. Now we know what's the problem and what are we going to help them. For that, we are going to think what we are going to use now. These are the six important things we are going to use for today's class. First thing is ESP32. Uh, it's like a controller. Very easily speaking, for computer, it's a motherboard. Like it's a motherboard of our project. This is basic controller which reads the value from the sensor and send those data to the Wi-Fi through any online portal. Then that Wi-Fi mobile will read the data. First thing. Second thing is rain sensor. This sensor is used to detect the rainfall in the field and send those values to the ESP or any microcontroller. Third thing is soil moisture sensor. This sensor, as I mentioned before, it is used to detect the moisture content of the soil. When the water level is high, the moisture content of soil will be high. When it has less water level, then it also indicates the same. It will be useful for the farmers. Then come to the DHT11. This is the sensor used to get the temperature humidity level of the environment. Next, we are going to use relay. Relay is also simple thing. It's a switch uh, used by triggered by the any controller. Using the controller with some data, we can trigger this relay. Third thing is LM393. It's a comparator module. It's used to compare the resistance level and capacitance level. So, just a module to compare the voltage. Okay. Apart from these hardware, we need two software things. One is the mobile app, and the one is RTDP. Mobile app is just a UI interaction where farmers can see the values. They can change the on off the switch. Those things, if farmer want to use it, they have to have a mobile app which can be and friendly. They can use it anywhere, anytime. Second thing is RTDP. RTDP means real-time database. That means whenever a data is got saved in the ESP or microprocessor or microcontroller, it has to save somewhere in the cloud so that our app or anything will retrieve that. For that database purpose, we use I specifically use Firebase RTDB, which is easier and user friendly. Many IoT developers, when they are start learning and when they are on the beginning stage, they use Firebase, ThinkSpeak. They are the some RTDBs used by us. Here I use Firebase. And for mobile app, we think mobile app creating is a bit difficult. It should be used by created by computer science engineers or something like that. But MIT make us possible. Even EC or electronic based guy can create a mobile app using MIT App Inventor. This is an online drag and drop source to create a mobile app for IoT guys. Okay. Then this is a small explanation why I'm going to use. As you see, this is the ESP32 microcontroller, which have inbuilt Wi-Fi. That means it can interact with the internet. This works on 3.3 volts DC and memory 520 kb. When we say 3.3 volts, we have to sorry, we have to check with the sensors which we are using with the, because some sensors will work on 5 volts, some sensors will work on 3.2 also, some sensors will work on different voltage. For the configuration, we have to read which sensor used with voltage level, from which microcontroller output voltage will be this much. We have to read the uh, data sheet of all the sensors and the microcontroller also. Data sheet is just a catalog of the sensor. It have all the information about the sensors, even sensors dimensions included. It will be there. Next, this is soil moisture sensor. Uh, did you see the two pin right here? Okay. This is used to read the moisture level of the soil. This basically works on the concept of capacitor. These two edge act as a capacity plate. When there is more water level there, the capacitance level will increase. Sorry. Okay. The capacitance value will increase, decrease, depends on the moisture level of the content. When the capacitance value varies, the output voltage value also varies. Using that simple capacitance algorithm, this soil moisture sensor is working. Then we see the rain sensor. When we see the soil moisture sensor works on the capacitor, this rain sensor completely works on the resistance level. This see the plate. This is the they are the conducting frame is added in between. When the water is poured on the water is an fuel conductor. Uh, According to the water level in the plate, the resistance value decreases. So voltage value gets increased. We can map the voltage value and get the uh, rain content in that area. This is LM393. Uh, you can see this chip. When the resistance value decreases, uh, this voltage getting increased. At one point of time, it reached 5 volts. Yes. Uh, Using this method, we can find how many percentage the rain content is there or soil moisture content is there. Then here comes relay. This is simply a switch. We will connect the positive and negative terminal here, and we have a data pin on another side. When we give some data to that pin, the switch gets toggled. That means the switch from on to off to on will be handled by that data pin. Okay. We now find the problem and we discuss the solution, what we are going to use. We are going to implement it now. Okay, before implementing, this is the workflow which I suggest and I used to this. We think first we have to sense the um, data from the sensors. We are using three sensors here. So first we have to get the data from the sensor one by one. Like first you have to get the sensor, the data from the rain sensor, then moisture sensor, then with the GSP. So likewise, we will get the data from those. Second thing is monitoring. Uh, for monitoring, we have to send the data to some other portal like mobile app, laptop, or something which is connected to a Wi-Fi. To monitor that, we need a RTDB, and now I'm using mobile app. Third thing is control. To control this thing, we have used some switch here. So this by this steps, we are going to implement our IoT in our sector. Okay, we are going to start coding on this. Um, Before going to the coding part, I suggest you few things. First one is IDE. That means a software where we can write a code and upload it to a ESP32 processor microcontroller. Now I'm going to use the Arduino software. Okay. This is our Arduino software. Here we write code for our microprocessor, microcontroller. This is usually used by the Arduino-based microcontroller, microprocessor like Arduino Uno, Mega, Nano. There are multiple processors there in Arduino. Uh, in beginning level, we'll be using the Arduino thing. For coding in Arduino, we're using Arduino IDE. Now I'm going to use ESP32, which also use Arduino's chip here, but it's Wi-Fi enabled one. For this, I make some compatibility changes in this Arduino software, so I can write the code here itself. Before going to the code, we can see two functions default is default in here. Those two functions are one is setup function and the one is loop function. As name suggests, setup function is run only once, where we usually write setup codes like few setup like to see the output in Arduino IDE, we use serial monitor. Okay. To run the serial monitor, we need a setup called serial dot begin with some baud rate. Baud rate changes microcontroller to microcontroller. Those setup things will be written in setup function, and loop function is our logic place where this function runs continuously. Like when we put while one and write a command, that command will have a continuous loop, right? This thing is exactly what that while loop do. So this loop thing runs continuously. It don't stop until we remove the power supply or upload some other program. Okay. So now I am going to write code on this. Uh, Before going to that, I like to show you the ESP module. Everyone can see my camera, right? This is the ESP module which I use. Usually it comes as a simple module. Uh, I myself make this solving connection. I hate wires. Wires will make us some bugs. So I hate wires. I make a solving connection. In this ESP module, we have multiple pins here. Okay. Uh, each pin have some requirement and some purpose. Here I'm going to use three pins. One is for the moisture sensor. See, this is our moisture sensor, and this is LM393. One is for my rain sensor, and then uh, this is my DHT temperature and humidity sensor. For three things, I'm going to write a code now, and we are going to implement it. Yes. First step, I'm going to write a code for rain sensor. Here I'm going to define which pin I am going to integrate my rain sensor with my ESP sensor. Here I gave name as rain analog, and I write a pin number as 27. So in ESP sensor, 27th pin, I connected with my rain sensor. This was the meaning of this line. And I go to the setup. As I mentioned, I'm going to begin my serial monitor with baud rate of 115200. This is a specific baud rate used by the ESP32 and ESP86 8622. Arduino's will use the baud rate of 9600. Okay, I begin the serial monitor. I initiate the pin number. Now I am going to get the data from the pin. I give some random variable name, and I am going to read as analog, the analog read, and I mention the name which I specified before. So by this sentence, I get the value, analog value. Now it will be in the form of 0 to 4096. The value length will be from 0 to 4096. So for our easy purpose, what I'm going to do is I convert it as a 0 to 100 scale. For that, I'm going to map map my rain value from 0 to 100 with sorry, from 0 to 95 to 0 to 100. So whatever value come between the 0 to 4095, it converts as a 0 to 100, which will be a percentage form. And I'm going to print it and see it in my serial monitor. This is a very simple code, but for different sensors, the code will vary. Basic underline of it is uh, basic underline of it is if you read as analog thing, you will be using analog read, or you will be using digital read, digital write, analog write. These are the methods to get it. But some sensors we need to do some background process. For those things, those sensors manufacturers itself release a library. We just want to import the library and use it for our purpose. So now we get the rain value. Now I am going to get the moisture value too. So what I am going to do is again for moisture value, I specified the pin number 32. Same for setup, nothing is needed. So now I'm going to get the moisture value as same as the analog values. Okay, it's simply a repo of what I did before. So by this methodology, I get the analog and digital values. Sorry, I get the rain and moisture value. So in my first step, the preliminary two sensors values over, I'm going to get data in for the third sensor. As I mentioned before, I'm going to use DSP11 sensor. As I said before, this sensor, we can get values directly from this sensor, but what output we expect, it won't come. It come as some random junk values. We may feel like so, but exactly what happened is inside this sensor, they make some changes so that the data will be in different format. To read that format, DSP11 itself released one library. So I am going to use that library, which make my work easier to get the values. So here I am going to include the library. My library name is DHT H Here all library name will come as .h files. As before, I'm going to define my DHT pin. Here I use pin number 4, and I'm going to use I'm going to say my DHT type, because in DHT there are multiple types: DHT 11, DHT 12, and DHT 40. There's various versions depend on the usage. I'm going to mention my thing, which is DHT 11. Okay. After this, I'm going to initiate a step. I'm creating an object called DHT. You all know the object thing. When you use a library or some other program, it has some classes. So we have to access those functionality. So those referrals. So we are going to initiate an object here. As object, I give the parameters. Okay, I created the object, and inside the setup thing, I am going to begin this object. DHT dot begin. Okay, by these steps, I started my project, and I created an object, and I begin it. Now I am going to get the value. If you go to the HT11 library package itself, they will give you the example how to read the the HT11 values in different formats. Out of those research, I came up with a few things. I get as a float value, float. I mention humidity at, and I'm going to read the function, read humidity with help of the object. Same like I'm going to read the temperature, DHT dot read temperature. Okay. Now this temperature, uh, by default it comes as a Celsius, but I need it as a Fahrenheit. So it's DHT dot read temperature. So, you can see the multiple colors will be there. One will be in blue, one will be in black, one will be in orange. Each thing specifies different reason. Blue is a predefined keyword, and the orange is a function. Okay. Yeah. Now we read the temperature, humidity, and temperature in Fahrenheit also. If we need, we can read the heat index in Fahrenheit, heat index in Celsius also. Depends on what we need, we can initiate the float value and read all those values. Okay. As our first step is over, we read the values from the sensor. Step 2, we have to send these data to the cloud. Okay. For that, I'm going to use the ESP32 Wi-Fi library. If I go to my library file, there will be a drop down called example. When we go bottom more, you'll be seeing ESP32. Go inside that. Sorry, ESP32. Yeah, it's here. When you see the Wi-Fi here, go to Wi-Fi client. There are multiple there. This program is to check whether our ESP32 Wi-Fi module is working or not. We will be giving our Wi-Fi ID and password here. Just upload this program in the ESP module. After uploading, just restart to our ESP module. It will show connection success. Wi-Fi is connected to this IP address. Like this, you will get the output. So we can find my ESP module working. So what I'm going to do now is um, I'm going to use the Firebase. Okay, for Firebase, I installed one more library to use the Firebase thing. So I'm going to Firebase and Firebase JSON basic. When I open this, it's a big program. So each program have each reason there. So just go to what the program is actually doing there. Okay. I'm not going to use all the functionality which is specified here. So I make a small program which is helpful for us to finish this project as soon as possible. So this is my program. Here you can see the Firebase host and Firebase hot. I will come back to this, what this is all about. And you can see the Wi-Fi ID and Wi-Fi password. This is my test Wi-Fi ID password, which is used to connect the internet. Then I make the object for Firebase data. I created two objects for two different reasons. I will explain it why I need two objects there. Then I make a JSON object. Uh, what's a JSON object? It's like a data type, string, int, float. We come to those data types. JSON also is a bit like a data type, the user-made data type, which is used for all web-based services, like for transferring data from one web to another one, or web client to web server, or like our device to web database. We use JSON. It's a universal data type where everyone uses. So I initiated it. These things all we started before we initiated the DST11, sorry, DST package and initiate those pins. Okay. Okay. Then here comes the stream callback. I will explain this when we go to the control side of the project. Now we are going to check the monitor side. Okay. I make a serial begin and I started my connection work. This thing will wait until my Wi-Fi is connected to the network. Okay. And these are the things used by Firebase. When you read the Firebase like this documentation, you will be understand why these things are things. It will be varies. For my project, I use these things. If you want to use some other thing in Firebase, you will be needed. You won't be needed this, or you will be needed something else. It depends on what you request. So always be ready to read the documentation. It will be helpful. Then here comes I read the humidity, temperature, and temperature in Fahrenheit. Same like I read the heat index value, and I read the moisture value, analog value, everything. Then what I'm going to do, I have to set all these value in JSON. So one by one, I'm setting the value to the JSON. After I setting these values, I'm going to push these data to my cloud. Okay. I wrote this code and I uploaded to the sorry, I uploaded to my ESP32. Now I am going to show my ESP32 now. Now you can see uh, my Wi-Fi is connected to this IP. That means this is my Wi-Fi network IP. Yeah, I'm going to restart it once again so you can see the process again. Yeah, now this thing is connected, and you can see the command call failed to read DST 11 sensor. This arises because yeah, this arises because I didn't connect my DST to this. So what I'm going to do now is I'm going to connect my DST sensor to my circuit. Okay. Once I connect it, you can see the light thing there, which indicates me it's working now. So now you can see the humidity temperature value there. Yeah. Okay. Same way, I'm going to connect my moisture sensor. Now you can see I just connected my rain sensor with my circuit and same way moisture sensor to my circuit. Now I'm going to open the app which I created. You can see the app. It's waiting for the data to come. I'll just make a small adjustment. Yeah. Now you can see the values appeared in my mobile app. You see how the values appeared there. I'll show you my Firebase database also. Rather than database thing, Firebase have many things for the developers and for the beginners who want to learn. If you are interested on this, I will just go through on it. You have multiple things, machine learning, function, hosting, storage. I am going to use the real-time database, as I mentioned before. Here you can see multiple data in JSON format, which is uploading. This is the recently uploaded thing. When I open, I can see the heat index values, humidity. While seeing itself, you can see multiple JSON is happening from our program. because I wrote those program in their loop. So what the loop thing actually does, it run the program continuously for n number of times. So here we finish our second step, like we read the sensor value and we send it to a mobile app or something where Wi-Fi is connected. So step two is over. Step three, we are going to control it. Like when we're going to control it, this is a reverse process what we did now. For monitoring, we send data from ESP32 to mobile. But when we control it, we have to send the data from mobile to ESP32. You can see a toggle button here. Okay. When I click this toggle button, I write a code just to on the light in my ESP module. So I'm going to achieve that function now. To go back here, uh, whenever I click a toggle button in my mobile app, it changes small thing in the database, but it won't come to our ESP as soon as possible. Whenever ESP makes a request only, it will know. But what happens is we have to reverse it. Whenever changes happen in the database, our processor should know that. For that, I make another Firebase object and I make a stream callback function. This function actually what it do is it waits for the data continuously in specific path. I give a path as slash motor slash data. It waits for this path. Whenever the value changes in the path, it immediately send those data to our ESP module. You can see it now. I'm going to press the toggle button. You see value is on. Again, I'm going to press the toggle button again. You see it is off. After I wrote the function, whenever we click the toggle button, it changes to on and off format. So I will show you how it works on my ESP32. You can see my toggle button, right? Okay, I'm going to on my camera so you can see it as well. Oh, sorry. You can see my ESP, right? I'm going to click my toggle button. You see a blue light is blink starting there. It was the switch works. Again, I press my toggle button. The switch gets off. By these things, instead of on and off the switch light here, I used to on and off the relay where we can send the value and we can on and off the motors there. So by this thing, uh, we end up with what we plan to do. Additional information, as I mentioned before, uh, to create a new app is MIT App Inventor. App Inventor. I open it and I just click create app page. It's an official website only, so don't be afraid of it. Here you can see my Smart app. Okay. I mentioned it before, there are two or three various databases there, but mostly I prefer to work on Firebase. One of the most important reason is this MIT App Inventor has inbuilt Firebase DB there. So without any much confusion or much struggle, I can integrate my Firebase with this. It's a so simple drop and drag and drop MIT app. I won't write any code here. I just drag and drop the user interfaces, layouts, whatever I needed. I just drag and drop it. And after I drag and drop, I have to write the logics in the block, like what the law happen is a very small. As we see this app do many things, but when we see the app begin this, it's so small. Like the logic begin this so small. That's what this MIT app inventors do for us. It make it as app, and we can build it or save the APK directly to a computer, and we can use it very easily. So these are the two important things apart from our hardware we use. One is MIT app inventor, next one is Firebase. So by this thing, we end up with a section. If you have any doubts, you can ask me.
Thank you, sir, for your stimulating and fruitful session. Now, let's move on to the question and answer session. First question: how to choose revisit time for precision agriculture?
Sorry, I didn't get you.
How to choose revisit time for precision agriculture?
Revisit time.
Yes, sir. Yes, sir.
Mm-hmm. Can you type it anywhere? I didn't get what you wrote. You can type in the chat box or somewhere else.
Can I read it again, sir?
Sorry?
Can I read it again?
Yeah,
If you post it in the chat box, it will be easy for
yeah.
him.
So I can see it.
Is it possible, Vinu, sir? It is possible for you now?
Sorry, ma'am.
Yes, ma'am. Yes, ma'am.
And again, I am asking our student.
Yeah, fine.
She will post it in the chat box.
Yeah. How to choose revisit?
Naveen, it is being posted.
Yeah. Yeah. Okay. They don't want to revisit actually because for this question agriculture thing, anyways, it's on the whole it's like spending some. Oh, sorry. Spending some water portion on all things will be monitored for specific thing. If you have to monitor the gas also, we have sensors there. So for what's the exact thing we have to monitor, we will make a sensor. We will get the sensor and implement it. So we don't have to visit the farming land itself for the small things. So we can get the value of that sensor there, and we can switch on and off those machineries. I hope I answered. Then next one, what are the different components used in smart IoT sensors? Okay, different components. Same here. I can make it so simply. This embedded thing is like cooking a dish. Uh, it depends on the components. This depend on the problem. What are the problem we are going to face, or what are the problem we are going to solution? We can implement it. As I mentioned before, we have a gas sensor to get this gas value of there if any moisture gas is there, or we have a pure PIR sensor to detect the motion there if any animal came in between, or we have small PIR or IR sensor to detect the even detect the insects in the particular leaf or particular thing. So it depends. We have sensors for everything. If we don't have, if you know the science behind this, we can invent our own sensor. This basic ideology we have to have. So in all sensors we can use in agriculture for a problem. Then how is greenhouse automation is done? Uh, Same way which I said now, but what we saw today is developer-based kits. These are for the beginners. So when we go to greenhouse automation, when we go into a big platform, they will be using the industrial grade kit. They will be using DSC-11 sensor in different manner. They have sub high precision thing. Uh, they will be having a high precision moisture sensor. It will be purely different, and it will be a bit high tech when we are going to process also. And they are using MI AI, I mean machine learning AI algorithm there. Simply, for instance, like a Jarvis like thing will be there, so they can do with help of all this. Their IoT is just in one part. They will having MI thing. They will be having some database structure. Everything all together will make it possible. Eh, Any other question?
So that's all. The question and answer session gets over. Thank you, sir. Now it's time to express our gratitude. On behalf of Electronics and Communication Engineering, St. Joseph Institute of Technology, St. Joseph Group of Institutions, I thank Mr. Naveen Kumar sir for enthralling speech on IoT in smart agriculture. Thank you, sir, for taking out time from your busy schedule and joining us to share your knowledge. My heartfelt thanks to our beloved chairman, sir, Dr. B. Babu Manoharan, for organizing an wonderful webinar to gain knowledge. My sincere thanks to our managing director, ma'am, Mrs. B. Jessie Priya, and our director, sir, Mr. B. Sasi Shekhar, for the guidance in conduction of the webinar. I would like to express my gratitude to our principal, sir, Dr. P. Ravichandran, for his support to conduct this webinar, and our department heads Dr. C. Jnana Kausalya ma'am, Staff and Student Affair, and Dr. G. Rohini ma'am, Lab Affair, for their words of encouragement and guidance, and our department staff and the organizing team for arranging this webinar successfully. And finally, my sincere thanks to all the participants for your active participation and support. Thank you all.
Thank you, Hepzibah. Naveen, thank you. Really, it was a very useful session.
Thank you, ma'am.
Yeah,
Thanks,
maybe our students will be able to do some projects in this area. Really, it was really it was answer, no? So some information they would have